Artificial intelligence. I'm going to go back to the history again. The first person to introduce artificial intelligence was Alan Turing. He wrote a paper that called Computing Machinery and Intelligence. And what was the test was basically you have a computer and a person that are hidden. And you have a second person, that's the judge, standing outside, doesn't know which is the person and which is the computer. And it gives them a question or a task to do. And when he sees the results, can he tell which is the human or can it not? So if it cannot tell, the Turing test is basically to exhibit if you can determine the difference. What we're trying to do now with artificial intelligence is to try to make it as the hardest to distribute, to understand whether it is a machine or a human. And here we have the father of AI, which was a computer scientist, and he applied this logic of the Turing test and created the first AI program. As it says here, is the science of engineering making intelligent machines, replicating human intelligence, of course, and intelligent computer programs. It's the interdisciplinary field, so it has so many other fields that go on in artificial intelligence. They deal with models and systems, and as I said, human intelligence. Here we can see AI subsets. Artificial intelligence has machine learning and deep learning. Machine learning is when you use statistical methods to improve with experience. So as it's called machine learning, it does learn. So you give him something and they will learn and will adapt accordingly. And you have deep learning, which is even more advanced, and it has multi-layer neural network features. I will give an example in a bit. So here I explain what it does. It identifies patterns, makes predictions, learns, and analyze data sets. It has many learning techniques, including linear regression, logistic regression, decision trees, support vector machines, and clustering algorithms. Again, I will show examples in a bit. And there is supervised and unsupervised learning. Here it is. Have supervised, unsupervised, semi-supervised, and reinforcement learning. And this is just the machine learning, not deep learning. And actually, you also have a part of supervised learning is deep learning. You have classification, regression, all of those things. And these are the concepts, and these are the type of algorithms that you can use. Here is an example of classification. As you can see, you have this data, and you want them to separate. The dots are this thing, and the triangle are this thing. So it can represent anything. It can represent a person and an object. And there you have regression, which you have all the data in one place, and you're trying to try and classification gives a pass fail, yes, no, and the regression gives a percentage. So if it's close to the line, then it's more likely to be that thing. So if you're looking for a human, if it's far, far away, then it's unlikely. So it depends on the application. You use different, these are the simplest I could find, but there are very, very much more complex types. And here's another example. What will be the temperature tomorrow? It's a degree, and classification, it will be cold or hot. So if you remember before I mentioned fuzzy logic, it works something like this. And this is how to confuse machine learning. So here we have some puppies and some muffins. If you give this data set to a machine learning, it will learn, it will think that this is the dog. If you teach him that that is the dog, then it will be identified as a dog. It doesn't matter that it's a muffin. That's what you taught them. And the same thing goes with the other puppies that looks like a fried chicken. If it looks like a puppy, it will also look like a fried chicken. So depending on your algorithms and your analysis, data sets and what images you use to train your models is very important in the programming stage. And here we have deep learning that uses complex pattern of data. And actually, I will skip, I will go here. This is a simple neural network that works in machine learning. So you have all of these are identified as, let's say, dogs. So you have all those and it compares and it could tell that's a dog. But if you have different kind of dog, or if you want animals, so you don't only want dogs, so you have dogs, zebras, and also, so you have so many layers and it can come as an output, yes, this is an animal. So obviously, if you don't need to have deep learning, it needs much processing power, you won't use it. You can use just a simple neural network. Here is an example again. All those are people. And you use one layer for face features, one layer for contrast, one layer for face. So depending on what you want to find out. If it's something complex as a human, of course, you will need deep learning for it. So this shows exactly how all of those work together. Again, you have the environment, the data, the feature extraction that we said. If it's an image, it has to be enhanced, it has to be analyzed. It goes to the model, it goes to the machine learning, and it does the decision making. All those work together.